Welcome back, viewers on YouTube. So in this video tutorial, we are going to consider proving the derivative of sine x. So let's take it first. It says that if y is equal to f of x and is equal to sine of x, then its derivative, the y dx, is equal to cosine x. So let's investigate why this is true. So we consider using the definition of derivative, which says that the y dx of any function f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Perfect. Now, if f of x is equal to sine x, what would be f of x plus h? So what it makes sense is that wherever you see x in f of x, just replace with x plus h. So therefore, f of x plus h will be equals to sine x plus h. Perfect. Now that we have everything we need, we can substitute back in the definition of limit. So therefore, the derivative, the y dx, will now be equals to the limit as h approaches 0 of f of x plus h, that's sine x plus h, sine x plus h, minus f of x, that's sine x, and everything entirely is divided by h. Perfect. Now at this point, to simplify more forward, we need to consider using some of the trigonometric identity. And this is the one we'll be considering using. The double angle or the compound angle formula. It says that the sine of two angles, A and B, is the sine of the first one times the cos of the second one plus the cos of the first one times the sine of the second one. So therefore we have the y dx to be equal to the limit as h approaches 0. So we now have sine of the first one, sine x, cos of the second one, cos h, plus cos of the first one, cos x, sine of the second one, sine h. Then we still have subtraction of sine x minus sine x, then we still have a division of h. Perfect. Now at this point, I would like to combine this term with sine x. So therefore, we now have it to be equal to the limit as h approaches 0. So combining sine x, we have sine x cos h minus sine x plus cos x sine h. Okay, perfect. And we see have a division of h. Okay, now at this point, I would like to factor out sine x. As you can see, it's common at this part. Then we have the limit as h approaches 0. So sine x is common. We have sine x as common. And left over is cos h minus 1. Then, okay, continuing, plus cos x sine h. And everything entirely is divided by h. So at this point, I would like to split the fraction, distribute h for this and this. So therefore, this is the same as the limit as h approaches 0. So I'm distributing the fraction. I have sine x multiplied by cos h minus 1 all divided by h, then plus cos x sine h all divided by h. Now, from properties of limit, we know that the limit of addition is equal to addition of limits. So I will distribute the limit for the two terms. And therefore, at this point, we have the limit as h approaches 0 of sine x cos h minus 1 all divided by h plus the limit as h approaches 0 of cos x sine h all divided by h. Perfect. Now, since the limit is such that it is with respect to h, it means sine x doesn't really have business with what with the concern. So therefore, we can take it as a constant out of the limit. Same thing applies to cos x. We can take it out of the limit, and therefore we have it to be equals to. So I'm taking sine x as a constant. I have sine x, the limit as h approaches 0 of cos h minus 1 all divided by h plus taking cos x also as a common or as a constant, cos x, we have the limit as h approaches 0 of sine h over h. Perfect. Now, from measurement of small angles, the limit as h approaches 0 of cos h minus 1 over h is equal to 0. This can be confirmed with your calculator. Just make sure your angles is in radian. Then you can just plug in the whole expression in your calculator. This is scientific. Then you will realize that the result will be 0. And if your calculator is not is scientific, you can plug in a very small number as cos h. Then subtract 1 from it and divide it by 0. Sorry, divide by the small number you are considering. You will realize that the result will be 0. Similarly, the limit as h approaches 0 of sine h over h will also be equal to 1. This can also be confirmed with your calculator. The result will still be 1. So if that is the case, these will become 0, and we have sine x multiplied by 0 plus cos x multiplied by 1. Since this entirely will become 0, and this will become cos x, then we can clearly say that the y dx is equal to cos x. And this is how the derivative of sine x is formed and why it is equal to cos x. I hope you find this helpful. Thanks for watching. See you in the next video. Bye for now.